So suppose f of x is a function and continuous on closed interval a comma b, differentiable on open interval a comma b. I got rid of the third condition, f of a equals f of b. If this is the case, so in mean value theorem, all we're saying is that if A and B are satisfied, there is going to be a C in the middle of A and B, which will satisfy this condition. F prime of C would equal to F of B minus F of A divided by B minus A. That part should remind you of something. What does it look like?
It looks like the quotient rule.
Difference quotient is okay, but simpler than that.
Well, it's just saying because generally.
Slope. That simply is the slope, right? If we call that y2, y1, x2, x1, that is simply the slope. So all we are saying is there is going to be some point C in the interval A to B where the slope at that point will match the slope that you draw between A and B. Yes.
What is that like you were saying before, like a straight line? Before you just drew a straight line without a slope, like it could be like A and B now.
So
Like A doesn't have to equal B at this point. So
exactly.
So f of c is equal to slope. Basically. Wait, so when, I'm not saying that it is a proof. Well, this seems like a proof to say at the very least about like a derivative being the slope of y.
It is just an illustration. So is f of A equal to f of B? No. F of A is over here. F of B is over there. Now I want to draw a line that would pass through the points both A and B. So how should this line go?
a straight line.
Yeah. So I could just draw a straight line over there. From A to B, yeah. From A to B. So it has to go through A and B. Let's see if I can draw it. Not bad. Okay. Correct. So I can easily find the slope over here. F of B minus F of A divided by B minus A. That will be the slope of this line. Okay.
But a differential, or is that, but when you're doing derivatives, that's the whole reason that you're doing it is literally just a tangent line that doesn't touch anything.
I have not gotten to the derivative yet. So all this is the average rate of change between A and B. Do you agree?
Yeah.
Now, what is another word that we use for average in statistics?
Mean.
Mean. Now, do you see why we call it the mean value theorem? Because all we are saying is this average rate of change is going to match up to the derivative instantaneous rate of change at some point C between A and B. Do you see such a point between A and B where the instantaneous rate of change, the derivative at a point C, will match exactly with that slope? Do you see that line? Come again? Okay. Could that C be right over there?
No.
No, how about that? How about that?
Yeah.
Yep.
Yeah.
No, yes, yes.
Yes.
So,
Like what a parallel?
So rate of change is equal to.
So, my poor artistry there, but it is touching at one point hypothetically, and it's not very powerful, but you get the point.
So for the other one, I understand how that makes us be able to save time and such. For this one, this is generally, if you're being asked about rate of change, this is basically a sort of math group way to go, hey, listen, you already know how to quickly understand how to get the average rate of change between these 2 points by applying the mean value.
By using the derivative. So,
This is interesting.
so there is a C where the slope that you got between A and B matches to that instantaneous rate of change. Yes, do we agree? My drawing is poor, but you get the point. They're parallel. Now, is that the only point though?
On the other one.
On the other one, there is one right here. Yes.
So are we going to get 2 C values?
5.
Well, what I mean is like, just generally, are we going to get multiple C values?
Correct.
Yes.
No, so the theorem doesn't say that there has to be only one C value. The theorem doesn't say that there has to be exactly 2 C values. All the theorem states is that there will be one C value, but there could be more. For instance, if I did something like that, I could see multiple C values in the middle. Good.
How would we find these other series?
Huh?
Considering we're still using the C.
I would do a tiny graph over there. Remember, I did a trivial case with Gauss theorem. Here is a trivial case. X, Y, f of A, f of B is the function straight line, continuous on A comma B? It is. Is it differentiable on A comma B? It is. This point, the slope between that point and that point would be the right-hand side. But is there a C between A and B which will satisfy this equation?
Yep, every single value.
Every single C between every single number between A and B will satisfy that equation because the instantaneous rate of change is the same as the average rate of change for a straight line.
Yep.
So we've got x cubed minus 3x plus 2 on the interval minus 2, 2. Calculator is your friend. You can graph it. If you graph it, you can see that that is continuous, differentiable on negative 2, 2. We want to say if there is a number C or more than one, in the middle, from negative 2 to 2, which will satisfy this. So first, I'm going to start with the right-hand side. I want to know what that value is, so all I have to find is f of 2 minus f of minus 2 divided by 2 minus of minus 2. Correct? So f of 2 minus f of minus 2 divided by 2 minus minus 2. If you plug it in, f of 2 is 8 minus 6 plus 2 minus f of minus 2 is minus 8 plus 6 plus 2 divided by 4. So I have 4 here. Six minus 8 minus 2 minus 2 plus 2 is 0. So minus 0 divided by 4, I get 1. So that is the right-hand side of mean value theorem. So now we just want to find a C which will satisfy this condition. I have to erase. Yes. 2 plus 2. 8 minus 6, 2. 2 minus of minus 2. Huh? Minus times minus is plus. 2 plus 2, 4. With me so far? John,
Okay, like what do you mean by like right hand side?
of this equation. Right hand side. What do you mean?
What do you mean by right hand? Is there a left hand side?
Yes, it's an equation. It's got 2 sides. Left hand side, right hand side.
Oh, does the sign split the sides? I know that sounds terrible.
I would hope so.
So now I'm lost.
Right? This side is the left hand side because it's to the left of the equal side. That side is the right hand side.
Everybody's got like the Monday brain.
It looks like a Monday thing, Monday fever.
Yeah, at least it ain't senioritis.
I'm not playing with it.
And I think it's not just that, it was a long weekend. That plays a part always. So I need to find a point, C, where the derivative of this function, x cubed minus 3x plus 2, would equal 1. So I'm going to take the derivative,
3x squared minus
3x squared minus 3, derivative of 2 is 0.
1 equals
So now we want to set this equal to
squared, which just 4 over 3, which equals x squared. And which I'm done with is
previously, what did we do? We always set that equal to 0 with Rawls theorem. Here, should I set that equal to 0?
you should set it equal to derivative of
So how do I find this? So I erase the So we want to find a C so that 3c squared minus c is equal to 1. This would mean 3c squared minus 3 minus 1 equals 0. Yes?
Will you label on the test what C you want, whether we're doing mean value, whether you want mean value theory or whether you're talking about?
Yes.
Oh, okay.
Yeah, always.
I just.
In the homework also, the problem will clearly state, whether to do mean value or Rawls theorem. So 3c squared minus 3 equals 1, 1 being the average rate of change, the right-hand side of mean value theorem. So I move the 1 to this side, you get negative 1. 3c squared minus 4 equals 0, which would imply 3c squared equals 4. C squared would be 4 divided by 3. C would be square root of 2, 4 over 3, plus or minus.
Wait, why plus or minus?
Square root.
Like with that.
We can split the radical. You'd have plus or minus 2 divided by square root of 3. So that will be 1 point something. Possibly 1.3. So plus or minus 1.3 approximately. Does that lie between -2 and 2?
Oh, yeah.
Yeah.
Yes. Could you go ahead and see what the point is? This is 1.15. I overestimated. So does it look like the slope between -2 and 2 matches with the slope at 1.15? The big graph. Does the instantaneous rate of change at 2/√3 match the average rate of change? We can verify this using the calculator. I'm quite certain it's going to match.